When you talk about VFL, it means a Visual Fault Locator. So I'm going to use these two VFL equipment to explain certain things. Number one, you can see that it has a CW off and glint. CW means continuous wave. So once you power it on, you see that the cable, the light comes out of the cable just continuously like that. But if you put it at glint, then it starts oscillating in every two seconds. Every two seconds, the pulse is released. So that's just the difference between the CW and the glint. And the third one there is a off. So when you decide to power it off, so that explains that. So all Visual Fault Locator has that. Then another thing that I want to show you here is about what is always cause a kind of misconception. Model HT minus 30, output greater than 30 milliwatts, while this other one is having model HT minus 10, output greater than 10 milliwatt. This does not translate that this one will go for 30 kilometers and this other one will go for 10 kilometers. It is a total misconception. So what that means is that this one that has a HT10 shows that when you power it on for your VFL function, you may see a weak red glow at the bend. For example, I've powered it on now. This is what is giving me at this bend for HT10. And if I power on the HT30 now and I try to create such bend, so the kind of red glow that I'm seeing at the bend is much more sharper, and because it produces more obvious red glow. So that is one difference between the HT10 and HT30. It does not translate that this one will go for 30 kilometers and does not translate that this one will go for 10 kilometers. It's a misconception, and that's why we are here. So HT30 does not mean that it can measure. That's another thing. This one that has HT30 does not mean that it can measure 3 times the distance of HT10. So what does HT10 and HT30, what does it mean? So HT30, as it is written here, is a greater, that's the output now, greater than 30 milliwatts, while HT10 greater than 10 milliwatts. So it's not about distance, it's about the output that this equipment propagates on the cable. So you know very well that 1 milliwatt means 0 dB. 0 dB. 1 milliwatt means 0 dB. 10 milliwatt means plus 10 dBm. Sorry, 1 milliwatt means 0 dBm, which is the output power of the optical. Then why 10 milliwatts means plus 10 dBm. Then, so if 10 milliwatt means plus 10 dBm, it means that once this equipment propagate light, it is bringing out 10 dBm output power. That is what is propagating inside the cable. While this one that has greater than 30 milliwatt is propagating plus 14.8 dBm output power into the cable, and which can be very hazardous because it's very powerful. So take home, this one has higher, greater output than this one that has greater than 10 milliwatts. So another thing that we will need to study in VFL is that when you look at what I'm viewing here, it has a eczema laser pulse at 650 nanometer class 1 laser product, both for the one of 30 and the one of 10. They produce they oscillate at 650 nanometer, and they both have class 1 laser product. What does that mean? We have different classes of laser. We have class 1, which is 650 nanometer. We have class 1M. We have class 2, which is less or greater, about 1 milliwatt. We have class 2M. We have class 3R, we have class 3B. Then we will have that class 3B is not 650, it's between 5 to 500 milliwatts. And we also have class 4 laser, which is greater than 500 milliwatts. So, but because of just for testing of continuity sake, all VFL, as you can see, is operating at the pulse at 650 nanometer. Whether laser 1, laser 2, laser 3, laser 4, it is not advisable to look at the light coming out from the testing equipment or testing cable. Thank you.